Hello everyone, good morning. I hope all of you are good and I am also fine. So today I will take one class from chemistry, that is thermodynamics. This thermodynamics you will get in physics and chemistry as well in class 11. Okay, and this lecture will help you for the preparation of NEET, CBSE, ICSE school preparation also. Okay, and the topics we will do is isothermal process. There are so many processes in thermodynamic process. 4 or 5, 6 processes are there. So from that we will discuss about the isothermal process is what. Before that we will discuss about what is first law of thermodynamics. Okay, so that is first law of thermodynamics. It is nothing but the law of energy. First law of thermodynamics is nothing but the law of energy. So what is the law of energy? It is state that energy can neither be created or destroyed. Okay, it can be only transferred. It can only be transferred from one form to another. Okay, so mathematically we can write it mathematically that is U equal to del U equal to Q plus W. So del U is what? Where del U equal to U2 minus U1, that is internal energy. Q is represented here heat and W is work done. Okay, so now we will discuss about isothermal process. Isothermal process. So what is it actually, sir? In isothermal process there are so many processes there in thermodynamics. So one is isothermal process. In isothermal process, temperature, the process in which temperature remain constant. In which temperature remain constant. Okay, so del T will be 0 here. Suppose this one is initial position of a system and there is final position. If it go in thermodynamic process, then here the position will be P1 B1, here it will be P2 B2. Okay, so in thermodynamic process P is directly proportional to PV equal to constant. Okay, in thermodynamic process PV equal to constant. Okay, so P1 B1 equal to, we can write P2 B2. So P1 by P2 we can write B2 by B1. Okay, this one is the one method or one formula of the thermodynamic process. The process in which a thermodynamic process in which the temperature remain constant is known as isothermal process. Okay, so now work done in isothermal process, how can you find it? So work done, number one formula is work done in isothermal process. We can find W iso is equal to minus 2.303 nRT log B2 by B1. Okay, or we can write minus 2.303 nRT log P1 by P2 also. This one is for reversible process. Okay, reversible process. And for irreversible process, what will happen? Work done will be work done will be P external pressure into del V, P del V. Okay, work done will be P into del V. So what we learn? We learn a little bit about first law of thermodynamics. So first law of thermodynamics is nothing but the what? First law of thermodynamics is nothing but the law of energy, that is energy cannot be created nor destroyed. Okay, it can be transferred from one state to another state. Got a point? Now mathematically we can write first of all del U equal to Q plus del V. Del U is here internal energy or change in internal energy. You can write Q is heat, W is work done. Now there are so many processes there in thermodynamic process. Number one is isothermal process. So what is isothermal process? The process in which temperature remains constant, that is delta is 0. Okay, so in the isothermal process we can find Pv equal to constant, that is P1 B1 equal to P2 B2 by P1 by B2 equal to B2 by B1, or graphically we can write graphically P and B is inversely proportional. It will be like that. Okay, it will be like that. It must P proportional to what? Here P proportional to 1 by B, is not it? So it will be like that. Achha. So work done. So we have to find out work done is isothermal process. So Wi is equal to minus 2.303 nRT log B2 by B1 or minus 2.303 nRT log P2 by P1 in terms of volume and in terms of pressure. And here N is number of moles, R is gas constant, and T is temperature. But this one is for reversible process. But irreversible process, in irreversible process, work done in isothermal process is W equal to external pressure into change in volume, E P X T into del V. Okay. So now from that, by using this formula, we will do some previous year question. Those questions came in NEET JEE. Okay. So let's start. Now our first question is like that: an ideal gas expand isothermally from 10 to the power minus 3 meter cube to 10 to the power minus 2 meter cube, and at 300 temperature against a absolute pressure is 10 to the 5 Newton per meter square. So this one is one container. Okay, the temperature is T is 300 Kelvin and pressure is what? 10 to the power 5 Newton per meter, and initial volume is 10 to the power minus 3. After you use pressure, its volume is increased. The final volume is 10 to the power minus 2 meter cube. Okay, so from the data we have to find out the work done on the gas. How much work is done on the gas? So we know that work done is equal to minus P(E)xt B2 minus B1. So pressure is 10 to the power minus 5. B2 is what, sir? 10 to the power minus 2 minus 10 to the power minus 3. So if I take common 10 to the power minus 2, here it will be 1 minus 1 10 to the power minus 1. So it will be 10 to the power 3 into 1 minus 1 by 10. So it will be minus 10 to the power 3 into 9 by 10. So it will be minus 900 kilojoule. Okay, minus 900 joule. It will be 900 joule. Okay, so work done will be 900 joule. Which option is correct? Option B is the correct answer. So let me explain again in short. An ideal gas in isothermal process expand. The initial volume is 10 to the minus 3 meter cube and final volume is 10 to the minus 2. Temperature is fixed in isothermal process. We know that the pressure is what? Pressure is constant pressure 10 to the 5 Newton per meter square. So we have to find out the work done. So work done is minus EPEXT B2 minus B1. So that is 10 to the 5, 10 to the minus 2, 10 to the minus 3. If I take 10 to the minus 2 as common, then it will be 1 minus 10 to the minus 1. So after LCM, what will left? It will left minus 900. Okay, 900 joule. So move on to the next question. Now our next question, and this question also came in NEET. Okay, the previous question also came in NEET. This question also came in NEET and JEE. So our next question, that is question number 2, is like that: 16 gram oxygen gas expand isothermally and reversibly at 300 Kelvin. So what is given here? Given 16 gram, that is W is given here. Okay, mass, and oxygen gas expand isothermally and reversibly. Reversibly, you have to remember this, reversibly, and reversibly means reversible. Okay, in reversible process. And volume is changes from this to this. There is B1 is 10 to the 10 decimeter cube and B2 is 100 decimeter cube. Okay, so here given initial volume, suppose this one is final volume, this one is B1 and this one is B2. So we have here it will be some work done. So work done is what we have to find out. And this one is oxygen gas. Here is what? Oxygen gas. Okay, oxygen gas is there. Now for oxygen, molecular mass of oxygen is what, sir? 32. So N will be what? W by M. That is 32 by 16. That is 2. Okay. Temperature is here given 300 Kelvin. So what is the formula of reversal process? So you have to remember, for reversible isothermal process, work done is what, sir? Work done W equal to minus 2.303 nRT log. What is given here? Volume or pressure? Volume. So we have to write in terms of volume, that is B2 by B1. Got my point? Now just put the value, all the values here. So minus 2.303 into N is what's at 2, and it is 8.31 into T is 100, and volume log 100 by 10. Okay, it will be log 10. 100 by 10, it will be log 10. Now minus 2.3, we can write 3.3, okay, into 2 into 8.3 into 300. Here it will be log 10. So log 10 is what, sir? Log 10 is 1. So 2.3, 2 into 8.3 into 300 into 1. If you multiply, it will came 2872 almost joule. That is near about what? This one. 2875, almost, we can write almost 2875. Okay. So which option is near? Option B is the correct answer. This one is not equal. 0 will be no. This one option and this one will be automatically cancelled. Okay. Isothermal process, there should be work done. 0 will not be there and D will not be there. So we have to find out which option is correct between B and C. So here minus is there. So since minus is there, so minus is, this option is automatically correct. If you want to calculate, so there is one shortcut method I will explain. Let's see, this option will not be there in isothermal process, and this option will not be there in isothermal and adiabatic process. So between these two, one option is correct. So in isothermal process, the work done will be always in minus form. So in reversible process, so 2875 will be the correct answer. You don't need any type of calculation here, but generally you have to do when you are in class 11 or 12. Okay, in school exam you have to do this one. That's why I am writing all this here. What is given? 16 gram of oxygen, so W is 16 gram, B1 is 10, B2 is 100, and M is 32 for molecular mass of oxygen, and T is 300, and N is W by M. I find out. Now for reversible process, W is what? This one. There are two formula in terms of volume, and this one is in terms of volume. Okay, in terms of volume of gas. So in terms of volume gas, there is a minus 2.3 nRT log B2 by B1. If you substitute all the values, then you will find what will get? It will be 2872 joule. It will be 2872 joule. Okay. Now we will move on the next question. Okay, that is question number 3. So students, our next question, that is question number 3 from the topic isothermal process. This is from thermodynamics part chemistry. Okay, this is the last question of the topic. This is the last question of this lecture. Okay, so calculate the work done. The questions like the calculate the work done when 1 mole of ideal gas is compressed reversibly. This is also reversible process from 1 bar to 4 bar at constant temperature 300 Kelvin. So the work done will be what? The work done is what? We have to find out. 4 option is given. Which option is correct? We have to find out. Okay. So here what is given here? Given P1 is 1 bar, P2 is 4 bar, and T is 300 Kelvin. Number of moles 1 is 1, and we know that R is 8.312. Okay. So work done in, therefore the work done in isothermal process, that is reversible, Isothermal reversal process is what? WIC equal to minus 2.303 nRT log P1 by P2. Log P1 by P2. Okay. So now you just put this value here. N is 1, R is 8.314, T is 300, and log P1 is 1, P2 is 4. So minus 2.303, 8.314 into 300. Here it will be log 1 minus log 4. So log 1 is what, sir? Log 1 is 0. Log 1 is, below log 1 is what? 0. So log 4. So 2.303, 8.314, 300 into minus log 4 is will be what? 0.5, approximately 0.5. So now minus it will be plus. So from that figure you can easily find out this option will be not and this option will be not. So what option will be correct? Between A and C. One option is correct between A and C. Okay. So if you multiply this one, you will get the answer is nearest. Sorry. If you multiply all of this, you will get 3 minus 3, 4, 5, 8 something approximate joule. So that is 3.4 kilojoule will be there, and minus will be cancelled, it will be plus. So W is equal to this one. So which option is correct here? This is not correct, this is also not correct, and this one is not correct. So option D is the correct answer. So option D is the correct answer here. Okay. Option D is the correct answer. So let me explain again. In the question they given pressure is P1, P2, P1 is 1 and P2 is 4, and temperature is 300 Kelvin, N is 1 and R is 8.31. We know that this one. So in the reversible process, in terms of pressure, the formula is like that. W is equal to minus 2.303 nRT log P1 P2. I just put all the values. After putting the values, I simplify this one, and if we simplify this, it will be become something like 3458 joules approximately, and this we can write plus 3.4 kilojoule. So option A is not correct, option B is also not correct, option C is not correct. So which option is correct? Option D is the correct answer. Okay, option D is the correct answer. So this much for today. I hope you enjoy my class, and thank you for watching. Take care.